Hello folks, and welcome to this introduction to complex ions. By the end of this lesson, you should be able to explain the nature of coordinate bonds within a complex ion and deduce relevant charges within or of complex ions. Now, complex ions are going to sound pretty strange because up until now, you take something like copper 2 sulfate, you toss it into water, you know it has high solubility, it's going to completely dissociate, and so you should have copper ions or copper 2 plus ions and your sulfate ions floating around, right? Sort of, not really. Now, the thing is that with these transition metal ions, what can happen is that they can actually form complexes with other things that exist in the solution that you have. Now, those other things are referred to as ligands, and those are all species that will have lone pairs of electrons. The lone pairs are actually important in here because of the way that they interact with those ions. Some examples of ligands you can typically see are going to be things like water, ammonia, carbon monoxide, chlorine ions, bromine ions, cyanide ions, and a few other ions and other substances as well. Now, those ligands have those lone pairs of electrons, which are then going to be able to form coordination bonds with those transition metal ions. You have a lone pair of electrons, you have your ion, which is going to be positively charged, so you have that electrostatic attraction, and with that you can actually form a covalent bond with it. So now you also have metals forming covalent bonds with other things. So here's an example of what one of these complex ions can look like. You have your iron ion, and you have all of these waters, which if it's in a solution, you're going to have plenty of, and then those lone pairs in the water can form a coordinate covalent bond or a coordination bond with that iron. Now, take a look at what's happening here in terms of the shape. Do you notice that there are 6 species that are bonding to that iron? And look at the structure of it as well. Does that structure look familiar? Hopefully it does. So this is a type of thing that can happen with any of these types of ligands, and again, a few more. Now, something that you might be asked to do is figure out what charges are going on inside or with these complex ions. So you might get a question where it says, deduce a charge of the following cobalt-2 complex ion. So here's a complex ion, you don't know the overall charge of it, so figure out what that charge is. Well, you know that you have cobalt, you know that it's a 2 plus charge because of the fact that the question tells you so, and then you have the complex forming with chlorine, and that chlorine that it's forming a complex with is going to be that chlorine ion. So let's take a look at how many of everything you have and figure out what the overall charge is going to be. So you have your cobalt, it has a +2 charge, and you have 1 of them. And then you have your chlorine, which has a -1 charge, and then you have 4 of them. So overall, this whole complex is going to have a charge of -2. You might be asked to do the opposite of it, deduce the charge of iron in the following complex. So here you go. We don't know what the charge of iron is, but we know we have 1 of them. Now, our next one is our hydroxide, and it has a charge of -1, and we have 1 of that. And then we have our waters. We do have 5 waters, but it has a charge of 0. So that's going to be 0 from that. The overall charge of everything is going to be +2. And so the charge on that iron is going to end up being +3. Now, the one thing that I want to caution you on and remind you of is be careful about what the question itself is asking for. If it's asking specifically for oxidation number, then you have to remember to put the charge before the number itself. If it's asking for just the charge, it doesn't really matter if you put the charge first or the charge last. Now, one other thing that I wanted to note is that with these complex ions, you do have a square bracket around the entire thing. So you can take this complex ion and then form an ionic compound with another anion on top of this, but the complex ion itself is a bundle. Like any other polyatomic ion, it is being held together by those covalent bonds. So you do need to keep it together, and it is referred to with these square brackets. And also, you may also notice that it's possible to have more than one type of ligand as well. And so these complex ions can get pretty complex. That's the end of this lesson. I'll see you next time.